you'll notice in this entire video that I did not use a calculator once. In further maths, I rarely use a calculator for these kind of questions. It's weird, it's really weird, and it makes me slightly uncomfy that I can do this kind of question without using a calculator, but you'll see what I mean in approximately 15 minutes. So hey guys, welcome back to my channel, and today I'm going to attempt to do what I think has been the hardest further maths question I have ever seen. Now, I do A-level further maths, if you didn't already know. How do you know someone's doing A-level further maths? They'll tell you. Yeah, it's very hard, and I have an exam on it next Friday, so why not do a hard question with you now to see if I can do it, to see if it comes up in my exam. Will I be able to do this standard of question? Now, this might just be a fun video to watch me struggle through if you don't do further maths. If you do further maths or are planning to do further maths, I highly recommend watching this because I will be uploading this if I get it right and if I've, got the method. And the method, I've seen a couple of questions similar to this before. The method is long, the method is complicated, it brings in pretty much everything across the entire course. So it's an exciting one, but yeah, let's get right into the question. Okay, so you can now see the question on the screen. Bit of a monstrosity, isn't it? The integral of the square root of x squared plus 4x plus 13 dx is equal to that, and you could be thinking, how on earth are you getting that? Well, let's do it. It's worth 15 marks. It's massive. It's a big question to be asked, and a long one at that too, and we're going to see how really long it is now. So let's just begin. I'm immediately thinking of hyperbolic substitution. You see I wrote at the top of the screen to remind me that that's the method I'm using for this. And I'm first going to complete the square to put it into an easier form to work with. So x plus 2 all squared minus 9 plus minus 4 plus 13 is equal to 9. I am going so fast that my head is going faster than I can speak, but you know what, we'll keep going. I can now use hyperbolic substitution to put in something that'll make it, into an easier form. If you've done maths, you'll know about integration by substitution. That's what we're doing here. It's just we're substituting with very different things. So I'm going to substitute 3 sine u is equal to x plus 2. So I'm putting 3 sine u into that bracket, pretty much. And then with any integration by substitution, you're going to differentiate both sides to get what dx is now going to be equal to. So I am going to say that if I integrate, or if I differentiate 3, not sine anymore, it's now cosh when you differentiate that, cosh u du by dx is equal to 1. Bring up the dx, which is an iffy thing to do, but it works in this. Cosh u du equals dx. We now know what dx is equal to, so we can substitute everything in. Now, let's rewrite our integral with our substitutions. So x plus 2 squared, we're substituting in 3 sine u for x plus 2, so it becomes 9 sine squared u plus 9. Then we also have our 3 cosh u du to put in. So there is our first step. Now let's tidy it up a bit. We can take out the 9 from that square root, factorize it out, and then square root it, you get 3, multiplied by the other 3, and now we have 9 times the integral of sine squared u plus 1. Oh, we still have our 3, or our cosh u now. Cosh u, don't forget about that, du. Now, if you do maths A level, you may be noticing something with our square root. It looks kind of similar to a substitution or a identity that you already know. It's slightly different with hyperbolics. We have cosh squared u minus sine squared u equals 1, which means that sine squared u plus 1 is equal to cosh squared u. We can now substitute sine squared u plus 1 for cosh squared u, and let's rewrite that integral. We have cosh squared u, and then we also have cosh u du. I forgot the u. Anyway, when we square root cosh squared u, we get cosh u, and then multiply it by cosh u, cosh squared u. So now we now have 9 times the integral of cosh squared u du. A lot nicer than the original one actually, but we can't integrate this because if you do ordinary maths, you'll know you can't integrate sine squared or cosh squared x, because there's nothing really to work out. You just can't do it easily. But you can use an identity. So we're going to use the hyperbolic identity, which is similar to the normal one you would use in ordinary maths, but different. So cosh, now I need to make sure this is very obvious, 2u is equal to cosh squared u plus sine squared u. And then cosh 2u is equal to cosh squared u plus, now sine squared u is equal to cosh squared u minus 1. So cosh squared u minus 1. And then when you tidy that all up to get what cosh squared u is equal to, cosh squared u is equal to half multiplied by cosh 2u plus 1. Now we're going to substitute that back in, and we're going to bring out the half to the front, and we now have 9 over 2 times the integral of cosh 2u plus 1 du. We can now integrate this, finally. So when you integrate this, we're going to get 9 times 2 multiplied by all of what we're going to integrate, cosh squared or cosh 2u. When you integrate that, you're going to get a half times sine 2u. So let me write that down. Half sine of 2u, because if you were to differentiate sine 2u, you would get 2 times cosh 2u, and we only have half of that. And then when you integrate 1, you get u. Plus c, of course, never forget plus c. And then we can multiply all of this by 9 over 2. So we now have 9 over 4 sine 2u plus 9 over 2u plus c. Now c will take a value, we don't need to work out what c is, and the 9 over 2 c is just a different constant. We could call it c dash, d, whatever. I'm just going to leave it at c, which is perfectly fine to do. So the 9 over 2 kind of disappears there. It'll actually be accounted for in the answer, but we don't need to worry about that. So we now have this equation, or not equation, it's just really a statement. We need to put our u's back in from the start, but there's still some things we need to do. Sine of 2u is a bit awkward to work with. We would rather have it in terms of sine u and cosh u. Luckily, we know another identity. We know that sine of 2u is equal to 2 sine u cosh u. Now I could actually prove all these, but I'm not going to prove all of them because this video will be like an hour long. So we can put that in to our statement, I guess. And we're multiplying, or we have it 2 in this, so we can now bring it back to 9 over 2 sine u cosh u plus 9 over 2 u plus c. Now let's take a break. Let's go back up to the top and let's see what kind of substitutions we had. We have 3 sine u is x plus 2. So let's rewrite this down here. 3 sine u equals x plus 2. This means that sine u, not shine u, it's not spelt like that. Sine u equals x plus 2 over 3. Great. But we also can work out what u is. So u is equal to inverse sine, or arc sine, depending on what way you've been taught. They're all the same thing. X plus 2 over 3. Now, we have another identity. Sine, or inverse sine, is equal to ln of, or natural log of, x plus the square root of x squared. Now I can never remember if this one's plus or minus. It does say in the formula book x squared. Let me just check. I am pretty sure it's plus. Yeah, x squared plus 1. That's equal to inverse sine of x. So that's another thing we can use later. You're also allowed the formula book, obviously, so if you need to look this up, I mean, that's perfectly fine. I look them up all the time because I forget. But that's another identity. Now, we can use what we've got here to do some things. So we have shine u coshu. Well, we actually know what shine u is equal to, but I wish we could get coshu into the form of shine u, because that would just be, you know, so much easier to work with, wouldn't it? Well, luckily, what we can do is we can say that 9 over 2 shine u and cosh u is equal to the square root of cosh squared u, obviously. But what's cosh squared u equal to? 1 plus shine squared u. So we have that. And then we also have 9 over 2. No, we know now what u is. So this is inverse shine of x plus 2 over 3 plus c. And we can also put in our shine u's. So 9 over 2. Our shine u is equal to, so x plus 2 over 3. That dot just means multiply, by the way, if you're not used to that notation. Multiplied by the square root of 1 plus x plus 2 all squared. That's a cubed, Jude. Over 9. I just squared that. And then we can also add our 9 over 2. Now, we now need to put this in logarithmic form, because if you go way back to the start of the question, it does ask for it in logarithmic form. So 9 over 2 multiplied by ln of, now we're substituting in our u, or substituting in our x. So we need x plus 2 over 3 plus the square root of x plus 2 all squared over 9 plus 1 plus c. Now we are veering into long answer territory here. We're getting closer to the answer. There's a lot of stuff going on here. Like, there's a lot going on. We're 10 minutes into this explanation already. You would do this a lot quicker because I wouldn't be explaining it in an exam, but yeah, it is complicated. Now let's simplify stuff. So 9 divided by 3 is 3, 3 over 2. We now have 3 over 2 multiplied by x plus 2 multiplied. Now the square root is going to be, if we multiply by 9 and then divide by 9, it's going to be, let me see, this is going to be x plus 2 squared plus 9, which is x squared plus 4x plus 13. And because we multiplied everything by 9, we need to remember that that needs to be square rooted and taken out. So that's over 3 now. I did all that in one step. You can do it in multiple steps, but I prefer to do it in one step. Plus 9 over 2, the natural log of, we have x plus 2 over 3 plus, now actually this is the same thing that we had in our other bracket, or other square root just before. So we actually know what this is. It's plus 1/3 of x plus x squared, sorry, plus 4x plus 13 plus c. Don't forget about our plus c. And now we're almost there. So in our first bit, we have 3 over 2 multiplied by x plus 2 over 3. 3's can cancel out and you get a half x plus 2 square root of x squared plus 4x plus 13. Then we have 9 over 2. Now we can factorize out 1/3 from this. So it's going to be a ln of 1/3 multiplied by x plus 2 times the square root of x squared plus 4x plus 13 plus c. And then you also have the rules of logs, where you can take out the ln of 1/3 and add it to the ln of the rest of that. So I'm just going to rewrite all of this again. Half x plus 2, the square root of x squared plus 4x plus 13 plus 9 over 2 ln third. That is really not a third. A third plus 9 over 2 ln x plus 2 multiplied by the square root of x squared plus 4x plus 13 plus c. We are very close to what the question asked for. However, we just need to take this part here, put it in our plus c, because it's just a random constant that you would have to work out if you were, finding a gradient or finding the original equation or something like that, but we don't need to do that, we don't have points to put in. But whenever we put that in, we get as our final answer a half x plus 2 times the square root of x squared plus 4x plus 13 plus 9 over 2 ln x plus 2 multiplied by, I'm going to put this in square brackets, plus the square root of x squared plus 4x plus 13. Let's close that square root, plus c, and that is exactly what we were asked for at the beginning. Now, I forgot that I'm not supposed to multiply actually. My plus sign disappeared. I'll put that back in now. There's a plus here, there is a plus here, and there's a plus there. So close. But yeah, I'll rewrite that one last time. So a half x plus 2 square root of x squared plus 4x plus 13. Am I still recording? I am, good. Plus 9 over 2 ln of x plus 2 plus the square root of x squared plus 4x plus 13. Got so used to writing the previous thing that I forgot about that plus c, but you see that the plus is there, and if I was doing this question and I realized I didn't have a plus, I'd look up and go, oh, I lost a plus. It's one of those things that happens to all of us. I didn't lose a minus, but I've lost a minus plenty of times in these kind of questions, but there you go. Let's zoom out a bit and see all the working out for 15 marks. That is a lot. That is a lot of working out for a 15-mark question. But that is all the time I have for today. If you did like this video and want to see more of these further maths questions or other things, don't forget to like, subscribe, leave a comment down below, do all that great stuff. But thank you all for watching, and I'll see you on the next video. Bye.